All right, so this video is on the sum rule or difference rule. And in the first video, we looked at the power rule. So what you can do is pause the video and just go through each example, and they get a little bit trickier as they go. So the power rule, all it states is if we have, say, x to the power of 4, this 4 will move to the front, and then here we subtract by 1. Okay, so we'll have 4x to the power of 3. And then you might see another situation, which might be 1 over x to the power of 4. So in this situation, we can't differentiate yet. We need to put it in a form where we can differentiate like this. This is equivalent to x to the power of negative 4. And now in this form, we can differentiate. We can differentiate this. Okay, so this would become negative 4x to the power of negative 5. And then from here, we can rewrite it like this. Negative 4 over x to the power of 5. Okay, so whenever you see 1 over and then the term you need to differentiate, you need to bring this to the top. All right, so the first one is really straightforward. So if I write it here, 5x plus 2. So just remember that this is going to be to the power of 1. Okay, so if we have a look at it again, this 1 will move to the front and it will multiply with the 5. So it will just become 5. And this is minus 1. Okay, so this will become 5x to the power of 0. Okay, so any term raised to the power of 0 is going to be 1. Okay, so whenever we have a term that doesn't have an x or a letter next to it, this will just become 0. Okay, when we differentiate. So all we're left with is 5 times 1, or just, so this will be 0, or just 5. Okay, so the solution to this first example is just 5. So just remember, this 3 is just going to become a 0. So we're just left with 0 minus. The 3 is going to move to the front. So it's going to be 30x to the power of 2. Okay, so that'll be the solution. Negative 30x, we don't have to worry about that. Negative 30x to the power of 2. All right, so the next example, we'll rewrite it again. We just go one by one. We look at each term and we try and differentiate each term. Okay, so this 2 will move to the front and we're left with 2x minus, the x will just become a 1 over 2. And that'll be the solution. All right, so in this example, we have 1 over 3 multiplied by this expression in the middle. A lot of the time, people make the mistake of making this a 0. Yeah, so if I rewrite it, so another way you can look at this is if we had, so for example, we can rewrite this like this: x to the power of 3 minus x is equal to y. So if this is true, then this will just be like this. This will be 1 over 3 y, right? If we differentiate this term, then this will have y to the power of 1. This will move to the front, and this will just be 1 over 3. Okay, so whenever you have an expression that you need to differentiate, you can multiply the final answer by what's in the front. So all we need to do is find the derivative of this in the middle and multiply it with what's at the front. All we're going to be left with is 1 over 3, and then this will become 3x to the power of 2 minus 1. Okay, so we're going to be left with 3x to the power of 2 minus 1 over 3. Okay, so for the next one, this will become, the 4 will go to the front, 4x to the power of 3 over 4 plus. So we need to rearrange this. We need to rearrange this in a way that we can differentiate this term. So this x to the power of 2 needs to come to the top. Okay, so here if we rewrite it, 1x to the power of negative 2 over 8. Okay, so we've rewritten it, but keep in mind we haven't differentiated yet. So we need to make it clear whenever we're solving the problems, we need to go step by step. So what we can do in order for us not to have to write too much, we can put this symbol at the top, like a little comma. And this comma means that we still need to differentiate this term, and this comma is called prime. Okay, so whenever you see this symbol at the top, it's just a quick way of saying you need to differentiate the term or the expression. Okay, so if we rewrite it, now we can differentiate this term. So this we keep the same. We can even simplify it, so these can cancel out. So we're left with x to the power of 3 plus, now we can differentiate this term. We're going to have negative 2x to the power of negative 3 over 8. Okay, so now we've differentiated both terms and we can simplify. We can further simplify. So this is just going to become x to the power of 3 plus, here we can simplify these two terms, or we can simplify this. This is going to be negative 1 over 4. And because we have a negative power at the top, we can bring that to the bottom. So we go x to the power of 3 here. And then this will be the final solution. This can be the final solution. All right, so in this example, we're differentiating a y. So it says that at the front. This can be rewritten like 1 y over 1 over 2 over 3. In this example, this 1 over 2 is going to come to the front. So we're just looking at this term first. So the 1 over 2 comes to the front and will multiply with the 1 over 3. And then we have multiplied by y, 1 over 2 minus 1. Okay, so that's the way of looking at this problem. We can look at it like this. So if we rewrite it here, 1 by 1 is 1, 2 by 3 is 6. And then we have multiplied by y, and this will just become a negative 1 over 2. Negative 1 over 2. And then this term will become y, negative 1 over 2 over 6. Okay, so that's just this term. So whenever you see something like this, you know that you can move this to the front and we're just multiplying. We're just multiplying the numbers like this. All right, so let's go back. We'll differentiate this entire expression now together. Okay, so we have, let's do it again. 1 over 2 times 1 over 3 y. And then this 1 over 2 becomes negative 1 over 2 minus. So remember, if we have square root of x is equal to x to the power of 1 over 2. So all we're going to have here is we're going to have 1 over 2 here. Y, 1 over 2. Because we haven't differentiated it yet, we can use this symbol, prime. And we can use it in the next step. All right, so next step, let's simplify this term here. So we have y, 1 over 2. This will be a negative over 6. Minus, now we can differentiate this. So if we have 1 over 2, and this will be same here, y minus 1 over 2. All right, so now we can see these two terms. We can add and subtract these terms because they have the same power. But what we'll do first is that we'll move this to the bottom so it's a little bit more clear. We'll get rid of these negatives. So we have 1 over 6 y to the power of 1 over 2, 1 over 2, y to 1 over 2. Now we can subtract these, but we just need to make these two numbers the same. So then that will be equal to 1 over 6y, to the power of 1 over 2, minus 3 over 6, y to the power of 1 over 2 here. Okay? And then we're just subtracting. We're just subtracting. So it's going to become negative 2 over 6, y 1 over 2. And then here, we just have negative 1 over 3, y to the power of 1 over 2. So this will be This will be the final solution.